Yes. Hello friends, welcome to the session. The subject is electrical and electronic measurements. Till now I discussed 4 chapters based on this measurement subject. Then 5th chapter is power measurement. Okay. This one important chapter for any competitive exams, mainly for GATE point of view and ESC point of view, engineering service exams point of view, or any other PSU's point of view also. Compulsory you can expect the questions from power measurements. This very important concepts. Okay. First we will start with mainly power measurement means we concentrate on DC power measurement and AC power measurement. Okay. Now with respect to power measurement, we have DC power measurement and AC power measurement. So DC power and we also concentrate on AC power. AC power. Then with respect to DC power measurement, we can use AV and VA methods. That is ammeter, voltmeter and voltmeter ammeter method. And you also use EDM wattmeter. EDM wattmeter. That is electrodynamometer wattmeter. Yes. Then with respect to AC power measurement, you have so many wattmeters are there. You also use, you can use EDM wattmeter, that is electrodynamometer wattmeter. Then we can also use induction wattmeters. Induction wattmeters. Then a ferrodynamic wattmeter. Ferrodynamic wattmeter. Can also use thermal wattmeters. Thermal wattmeters. Like this, so many wattmeters are there to measure the AC power. Then AC power is also measured by using, one is 3 voltmeter method. 3 voltmeter method. Mainly single phase AC power. Single phase AC power is also measured by using 3 voltmeter method. Can also use 3 ammeter method. 3 ammeter method. We can use 3 voltmeter method and 3 ammeter method. Yes? Now tell me. Yes. But according to syllabus, we have the concepts only on electrodynamometer wattmeter. That is, electrodynamometer wattmeters are used for both AC and DC. These are used for both AC and DC. We can measure the AC power, we can also measure the DC power by using EDM wattmeters. But according to syllabus, mainly concentrate on EDM wattmeters only. And one small concept in DC power measurement, you'd see the AV and VA methods also. But we don't have any concepts with respect to these wattmeters. But at the end, I will give some comparison between EDM wattmeters and induction wattmeters. But we don't have any syllabus on ferrodynamic and thermal wattmeters. And I will give one formula for 3 voltmeter method and 3 ammeter method. Okay, this not important, not there in syllabus, but I will give the one formula for each. The 3 voltmeter method I will give one formula, 3 ammeter method is also I will give one formula. In future may expect the questions. Okay, if it is asked, you ready to answer. Here throughout, if it is given that wattmeter means you take electrodynamometer wattmeter. Again, no need to every time no need to tell that EDM wattmeter like that. Generally, wattmeter means you take the EDM wattmeter. If it is mentioned that thermal wattmeter, induction wattmeter, ferrodynamic wattmeter, then only you can consider those wattmeters. But generally, wattmeters means you take the electrodynamometer wattmeters only. That is fixed. Okay. Now, first I will start with the DC power measurement using AV and VA method. Then later on we go for the electrodynamometer wattmeter. Starting I will give some construction details. Then how to measure the single phase power. Then how to measure the three phase power. That concepts you concentrate. Okay, first I will start with the DC power measurement using AV method and the VA method. DC power measurement using AV and the VA method. Yes. This is one small concept. Yes. First one is AV method. AV means ammeter voltmeter method. Yes. Ammeter voltmeter method. Ammeter voltmeter method. Yes. Tell. How we can measure the DC power by using ammeter voltmeter method. The name itself it indicates that first connect ammeter, next connect voltmeter. We know that in general ammeters are connected in series, voltmeters are connected in parallel. The name itself it indicates that first connect ammeter. Yes. Ammeter is connected in series. Next connect voltmeter. Voltmeter is connected in parallel. Yes. Voltmeter is connected in parallel. This combination is used to measure the power in a resistive load. That the load is RL. IL is the current through the load. VL is the voltage across the load. Okay. Now we are giving the DC supply. This is plus, this is minus. Yes. Now let the input resistance of voltmeter is RV. Let the current taken by the voltmeter is IV. Here we are doing the exact analysis. That's why I taken current to the voltmeter also. But ideally, the input resistance of voltmeter is infinity. That I already told that. Ideally, what is the input resistance of voltmeter? Infinity. If the input resistance of voltmeter is infinity, then what is the current taken by the voltmeter? 0. But that is ideal case. But here I want to do exact analysis. That's why I taken the voltmeter is also taken. Practically, every voltmeter takes some current, because it is not infinite resistance. That's why I taken IV. Now, first we concentrate on what is the true power. What is the true power? A true power is nothing but a actual voltage across the load into actual current through the load. That is VL into IL. VL into IL. Now tell me. Now, what is the measured power? How we can measure the power by practically using AV method? How we can measure the power? Yes. I think all are conducted experiment in our laboratory. AV method and VA method. In measurement laboratory you conducted this experiment. Then how you are measured practically? Yes. You connected voltmeter, you connected ammeter, take the voltmeter reading and take the ammeter reading, multiply those two, then you can get the measured power. That is, then measured power equal to voltmeter reading into ammeter reading. This is a measured power. Okay. True power is nothing but a actual voltage across the load into actual current through the load. Now, measured power equal to, what is the voltmeter measures? Voltmeter is exactly connected across the load now. That's why it measures VL. VL into. Now, what this ammeter measures? What this ammeter measures? You tell me. This ammeter is not only measures the load current, it also measures the current taken by the voltmeter. Okay. Now, what this ammeter measures means, This IL plus IV. Yes, IL plus IV. Then what is the measured power equal to? VL into IL plus VL into IV. Then what is the measured power minus true power? Measured power minus true power equal to VL into IV. This is measured power equal to VL into IL plus VL into IV. Then what is VL into IL? True power. You bring this side. Measured power minus true power equal to VL into IV. But I want percentage error. Then how to write percentage error, you tell me? Percentage error equal to measured power minus true power by true power into 100. Yes, measured power minus true power equal to true power by measured power minus true power by true power into 100. Then percentage error equal to, what is the measured power minus true power we calculated? VL into IV by, what is true power? VL into IL into 100. But I want one standard formula, that's why I am simplifying like this. Yes, percentage error equal to, how to write IV, you tell me? IV equal to current taken by the voltmeter, VL by RV. How to take IL? How to write IL? VL by RL into 100. Then percentage error equal to RL by RV into 100. In AV method, what is the percentage error? In AV method, what is the percentage error? Percentage error equal to RL by RV into 100. This one formula you remember. Yes, quick note down. How we are doing the analysis, not the final formula. How we are doing the analysis, that steps also you concentrate to solve any model or problem if it is asked. Okay. Then percentage error equal to RL by RV into 100. This one point to remember with respect to AV method. Now from this I want to write so many other points also, that is also important for competitive. Yes, the percentage error equal to RL by RV into 100. One observation here, if RL is reduces, or the percentage error reduces. RL is reduces, percentage error is reduces. Hence, this method is more suitable to measure the power in low resistive loads, because error is reducing. Low resistive loads. That means if you use this AV method for low resistive load, we can measure the power with less error. More accurately we can measure. That's why this method is more suitable for to measure the power in low resistive loads. Next, one more observation. Tell me, in this AV method, error is due to which meter? Is it error is due to voltmeter or ammeter or both voltmeter and ammeter? See one observation here. For example, if the current taken by the voltmeter is 0, in this analysis, if the current taken by the voltmeter is 0, then we can get measured power equal to true power. Then error becomes 0. That's why the error is because of current taken by the voltmeter. That's why in this method, error is due to voltmeter. In this method, error is due to voltmeter. Yes. Error is due to voltmeter. That point also you remember, error is due to voltmeter. Yes. But simply you remember like this. No need to by heart, simply you remember like this. The meter which connected at load side, that gives error. Simply remember like that. The meter which connected at load side, that gives error. In AV method, which meter is connected at load side? Voltmeter. That's why error is due to voltmeter. In VA method, voltmeter ammeter method, which meter is connected at load side? Ammeter. Then error is due to ammeter. Like that you remember. We know that measured power equal to true power plus VL into IV. Then simply remember like this. Therefore, measured power equal to true power plus power consumed by voltmeter. Power consumed by voltmeter. Yes, measured power equal to true power plus power consumed by voltmeter. This formula also simply you remember like this. The meter which gives the error, which causes the error, that meter will consume the power. For example, if the question asks like this, in AV method, measured power equal to dash. No need to by heart. In AV method, measured power equal to dash. Yes, in AV method, voltmeter is at load side. Then the error is due to voltmeter. Therefore, measured power equal to true power plus power consumed by voltmeter. The meter which causes the error, that meter will consume the power. Like that you remember. If it is asked like this, in VA method, measured power equal to dash, measured power equal. In VA method, ammeter at load side, then which consumes the, then which is the reason for error? Then ammeter causes the error. Then measured power equal true power plus power consumed by ammeter. The meter which causes the error, that meter will consume the power. Therefore, measured power equal true power plus power consumed by voltmeter. Therefore, if measured power equal true power plus power consumed by voltmeter means, then which power is greater? Measured power is greater than the true power. Okay. This is the points you remember with respect to AV method. Quick note down. Yes. The next one is VA method. Concentrate on VA method. Yes, it's over. It's write down VA method. This voltmeter ammeter method. Yes, voltmeter ammeter method. Yes, now tell me. The name itself, it indicates that first connect voltmeter, next connect ammeter. We know that voltmeters are connected in parallel. Then ammeter is connected in series. Then we are measuring the power in resistive load. It is a DC power measurement. Okay, this is RL. This is IL. Let the voltage across the load is VL. The supply voltage is V. This plus minus. Let the voltage across the ammeter is VA. The input resistance of ammeter is RA. Okay, voltmeter ammeter method means the name itself, it indicates that first connect voltmeter, next connect ammeter. According to that, you draw the circuit. We know that voltmeters are connected in parallel, ammeter is connected in series. Now, same procedure you follow. Tell me what the true power. True power equal to actual across the load in actual current through the load. Yes. Can you tell what the measured power equal to? Yes. Measured power equal to voltmeter reading into ammeter reading. Therefore, measured power equal to what the voltmeter reading? What the voltmeter measures? Yes. This voltmeter measures voltage across ammeter and voltage across the load. That is VA plus VL. VL into what is the ammeter? Ammeter is connected exactly in series with the load. Na? Then what is the ammeter reading? IL. Then measured power equal to VA into IL plus VL into IL. Okay. Then shall we write like this? This VL IL is nothing but a true power. Then measured power minus true power equal to VA into IL. But I want a exact formula. That's why I am doing like this. What is the percentage error? Percentage error equal to percentage error equal to measured power minus true power by true power into 100. Then what is the percentage error? Percentage error equal to what is the measured power minus true power? VA into IL. Yes, VA into IL by VL into IL into 100. Then what is the percentage error equal to? That is VA by VL into 100. Then percentage error equal to, how to write VA you tell me? That is the voltage across the ammeter. How to write voltage across the ammeter? IL into RA by IL into RL into 100. Yes. Now what is the percentage error? Yes. Then what is the percentage error? The percentage error equal to, therefore percentage error equal to RA by RL into 100. Okay, this formula you remember. RA by RL into 100. Okay, now one observation here. If RL is increases, or the percentage error reduces. Yes or no? If RL is increases, percentage error is reduces. That means if you use this method to measure the power in high resistive load, we can measure the power with less error. Less error in the sense more accurately we can measure. If RL is increases, percentage error is reduces. Hence, this method is more suitable. This method is more suitable to measure the power in high resistive loads. High resistive loads. This method is more suitable to measure the power in high resistive loads. Clear? Next, one more observation. Tell me, in this method error is due to which one? Voltmeter or ammeter? Yes, ammeter. The meter which connected to load side that gives the error. Na? Yes. In this method, error is due to ammeter. Parallelly note down, don't wait. In this method, error is due to ammeter. The ammeter which connected at load side that gives the error. Therefore, measured power equal to true power plus S. Which the error is due to which one? Ammeter. Then which consumes the power? Ammeter will come. That is power consumed by ammeter. That is here. What is the power consumed by ammeter? VA into IL. That is true power plus power consumed by ammeter. Power consumed by ammeter. Then measured power equal true power plus power consumed by ammeter means then which is greater? Measured power is greater than true power. Okay, this is analysis of voltmeter and ammeter method. Quick note down. Okay, this is the measurement of DC power by using AV and VA method. But here one point I am giving here that you concentrate. All this without doing this analysis also, directly you can tell that what is the percentage error in voltmeter ammeter method, what is the percentage error in ammeter voltmeter method. Okay, then how to write means, take the ammeter voltmeter and voltmeter. Once you know the percentage error, then you can write any point. Then you can write any point. Okay, in ammeter voltmeter method, error is due to which one? Voltmeter. Voltmeter means RV. Yes. Clear? In voltmeter ammeter method, error is which one? Ammeter. Error is due to which one? Ammeter. Then ammeter means voltmeter ammeter method, error is due to which one? Ammeter. Then RA. In both, which is common is present, RL is present. Okay. Now I want to write the formula in percentage error. Percentage error in AV method. Okay, always high resistance in the denominator, like that you take. If you take a high resistance in the numerator, means that gives a greater than 100%. That is meaningless. That's high resistance in the denominator. High resistance in the denominator means in RL and RV, which is high resistance. Yes, voltmeter is high input resistance. I told already. In the selection of voltmeter, the minimum resistance of voltmeter means 10 times of RL you select to reduce the loading effect. That's why high resistance in the denominator means RL by RV into 100. Then which is RA is high value or RL is high value? RL is high value. High value in the denominator. Then what is the percentage error? Percentage error equal to RA by RL into 100. RA by RL into 100. Okay. Now this is percentage. Now you can write any formula. You can write any point. That is, if RL is reduces, percentage error reduces, hence this method is more suitable to measure the power in low resistive loads. If RL is increases, percentage error reduces, hence this method is more suitable to measure the power in high resistive loads. It is low resistive loads, then it is high resistive loads. Then it is asked what is the measured power formula. Measured power equal to true power plus which is the error due to voltmeter. Then which meter will consume the power? Voltmeter. Then measured power plus power consumed by voltmeter. In VI method, error is due to which one? Ammeter. Then what is the measured power equal? True power plus power consumed by ammeter. Then measured power is greater than true power. Measured power is greater. Like that you can write. That means here what I am telling here, without doing the analysis, how to write the formula. Like this you remember. Okay. But during writing these formulas, you remember one statement, always high value in the denominator, then you can write the any formula. Clear? Okay, this about DC power measurement using AV and VA methods. Clear? Concentrate. Now before starting the wattmeters, I want to complete how to measure the AC power using 3 voltmeter method and 3 ammeter method. After that, I will discuss the wattmeters. With that measurement of power using voltmeters and ammeters will be completed. But using 1 voltmeter and 1 ammeter, we can measure only DC power. But by using 3 voltmeter method and 3 ammeter method, we can measure AC power also. Then we will see how to measure the AC power by using 3 voltmeter method and 3 ammeter method. One more point to remember, if the load resistance is known value, using single ammeter also we can measure the DC power. For example, if this RL is known value, then we can connect only ammeter, no need of any voltmeter also. The supply is DC supply, I am talking about DC supply. Then we can measure the current. Let this is IL. If load is known value, using single ammeter, also, which is measured, DC power is measured. Then we can measure what the current, then what the power equal to IL square into RL over. This current is measured by ammeter, already load is known value, then we can measure the single ammeter. That is also DC power measurement. Now AC power measurement. First I am explaining AC power measurement. First I want to discuss AC power measurement using 3 voltmeter method and 3 ammeter method. AC power measurement, for example, V equal to Vm sin omega t, then I equal to Im sin omega t. Then you tell me what the instantaneous power. Instantaneous power equal to V into I. Then what we get? Vm into Im sin square omega t. Shall you write like this? Instantaneous power equal to Vm Im by 2 into 1 minus cos 2 omega t. Then what the supply we are giving? Vm sin omega t we are giving. What is the frequency of supply? Omega. What is the frequency of instantaneous power? 2 omega. Therefore, if frequency of supply is F, then the frequency of instantaneous power is, Then the frequency of instantaneous power is 2F. Instantaneous power. Then the frequency of instantaneous power is 2F. Okay, this point to remember. Okay, this is the instantaneous power equation. But you have one doubt, sir. You taken that V equal to Vm sin omega t, I equal to Im sin omega t. That's why we are getting like this. But when I take V equal to Vm sin omega t equal to I equal to Im cos omega t, can I get 2F frequency? Yes. You multiply with Vm Im into sin omega t cos omega t. Divide by 2 and multiply by 2. 2 sin omega t cos omega t. 2 sin A cos A sin 2 omega t. Then what is the frequency? 2 omega. 2 omega in the sense 2F you take. That's why if the frequency of supply is F, then the frequency of instantaneous power is 2F. That you know in the case of AC supply. In the case of AC supply, in the AC power measurement. Now, here I want to discuss AC power measurement by using 3 voltmeter method and 3 ammeter method. Okay, later I will start the wattmeters. First one is 3 voltmeter method. AC power measurement using 3 voltmeter method. First you concentrate how to connect these 3 voltmeters. Yes. 3 voltmeter method. Yes, the name itself it indicate that connect the 3 voltmeters. Is a connection of 3 voltmeters. That this is V1. But before that, one point to remember. This 3 voltmeter method is used to measure power and power factor. Not only power, you also measure the power factor. The condition is load must be reactive. load must be reactive. Then only this method is applicable. If you want to measure the AC power by using 3 voltmeter method, whatever the load we are considering, that load must be reactive. Then only this method is applicable. Then how to connect 3 voltmeters? This is V1. This V2 voltmeter. This is V3. We connect 3 voltmeters like this. Sorry, load must be reactive. Let I am assuming some reactive load. It may be lagging power factor load. Let this is IL, or you take the load current is I. This is V3. This is V2. This is V1. I am explaining for AC supply because AC power measurement. Single phase AC supply. Okay, this is phase, this is neutral. Okay, this is a circuit we can use to measure the AC power by using 3 voltmeter method. Okay, now this is reactive load. Reactive load. Then only this method is applicable. It's just like, for example, you studied in the AC analysis of circuit theory. If the two resistors are like this, if the two resistors, this is R1 and this is R2. This is V1, this is V2. How to write V equal to V1 plus V2? It is the arithmetic sum. This you studied. For example, one resistor and one inductor is present. Let this is V1, this is V2. Then how to write V equal to square root of V1 square plus V2 square. Okay. Now this is resistive, but this is inductive, but is not a pure inductor. Understood? Then how to write resultant V, you tell me? This is, I want this is resultant V. This V2 is voltage across the resistor. This V3 is the voltage across the reactive load. Then according to parallelogram law, here it is a pure inductor cos 90, V1 square plus V2 square plus 2 V1 V2 cos theta. Theta is taken as a 90 degrees. Okay, but it is a inductive, it is a reactive load. It also consists of resistor and inductive. Then how to write according to parallelogram law? V1 square equal to V2 square plus V3 square plus 2 V2 V3 cos pi. Then correct? This I am writing directly, no need of any vector diagrams, all these. Then from this, what is cos pi equal to? Cos pi equal to V1 square minus V2 square minus V3 square by 2 V2 V3. This is the measurement of power factor using which method? 3 volt. Direct formula also you can expect. You ready to answer? This is the power factor measurement using 3 voltmeter method. Okay, this is voltage across resistive, voltage across inductive. According to parallelogram, I am writing. This is a power factor measurement using 3 voltmeter method. Then I want to write the expression for power measurement. Shall we write like this? Cos pi equal to, I am modifying this one, V1 square minus V2 square minus V3 square by 2 into, how to write V2? I into R I am writing. That is I into R V3. Then this V3 I bring this side. Then V3 I into cos pi equal to, then V1 square minus V2 square minus V3 square by 2R. What is V3? Actual voltage across the load. What is I? Actual current through the load. Cos pi is load power factor. Then VI cos pi gives AC power. Therefore, in a 3 voltmeter method, what is the single phase AC power equal to? V1 square minus V2 square minus V3 square by 2R. Okay, this is the formula you remember. These two formulas you concentrate in the measurement of power factor and power. But notation is important. This I taken V1 is input, next V2, this is V3. Okay. With this sequence only I given this formula. For example, here V1, V2, V3 given means then you take V1 square minus V2 square minus V3 square. Sorry, this is V1, this is V2, this is V3 means then what you can write V3 square minus V1 square minus V2 square like this. V1 square minus V2 square minus V3 square. With this sequence, this formula is applicable. If you change this one, according to that, change the notation there. Okay. This is about power measurement and power factor measurement by using which method? 3 voltmeter method. Quick note down. Then what about 3 ammeter method? Concentrate on 3 ammeter method. How to measure the AC power by using 3 ammeter method. Yes. Use it to measure power and power factor. Use it to measure power and power factor. Use it to measure power and power factor. Yes. Then how to load must be reactive. Condition is then only this method is applicable. Even in this case also load must be reactive. If it is a resistive, can you apply this formula according to parallelogram law? If it is a resistive, then it is not a arithmetic, it is not a vector sum, it becomes arithmetic sum. Then you cannot measure the power factor and power. Load is reactive, then only this method is applicable. Load must be reactive. Then how to connect 3 ammeters? This is the connection of 3 ammeters. Let this is A1. This ammeter is A2. This is A2. And this resistive. And this is A3. We connect 3 ammeters. To measure the power in reactive loads. Let us assume that either lagging or leading. Either lagging loads or leading loads, no problem. Yes. Then we are giving single phase AC supply. Okay. Let this current is I1. This current is I3. This current is I2. This voltage is V. Same concept. For example, if the 2 resistors are like this, 2 parallel resistors, this is I, this is I1, this is I2. How to write I equal to I1 plus I2? This concept you know. For example, if there is one resistor, one inductor is given. That this is I1, this is I2, this is I. Then how to write I equal to I1 square plus I2 square? Here you take an arithmetic sum, here you take an vector sum. Then apply same concept here. This is resistive, this is reactive. Now I want to write the expression for I1. Then according to parallelogram law, how to write you tell me? According to parallelogram law. Yes. How to write? Then I equal to or I1 square equal to I2 square plus I3 square plus 2I2 I3 cos pi. Correct? Now, what is cos pi equal to? Then power factor cos pi equal to I1 square minus I2 square minus I3 square by 2I2 I3. This is a measurement of power factor using 3 ammeter method. This formula important. This is a measurement of power factor using 3 ammeter method. Then how to measure the power? Then shall you write like this, cos pi equal to I1 square minus I2 square minus I3 square by 2 into, how to write the expression for I2? This is V means what? This voltage is also V. Because voltage across ammeter is negligible, this is V means this is also V. Then how to write I2 equal to V by R? I2 equal to V by R into I3. You bring this VI3 this side. VI3 cos pi equal to R by 2 into I1 square minus I2 square minus I3 square. What is VI3 cos pi? V is actual voltage across the load, I3 is the actual current through the load, into power factor gives AC power. Therefore, what is the single phase AC power? AC power using 3 ammeter method. R by 2 into I1 square minus I2 square minus I3 square. Direct formula also we can expect you ready to answer. This is AC power measurement using 3 ammeter method. Okay, this in 3 voltmeter method 2 formulas, in 3 ammeter method 2 formulas. You concentrate. This 3 voltmeter method and 3 ammeter method is particularly for AC power measurement. Voltmeter ammeter method, ammeter voltmeter method particularly for DC power measurement. We can also measure the DC power using single ammeter by knowing the resistance value. Understood? Okay. This you concentrate. Okay. This about DC power measurement and AC power measurement using the 3 voltmeter and 3 ammeter method. But for competitive point of view, very important concept is how to measure the AC power by using EDM wattmeter. EDM wattmeter can also be used for DC power measurement, but mainly concentrate on AC power measurement using EDM wattmeter. Generally, wattmeters means you concentrate on EDM watt, electrodynamometer wattmeter. In the next session, we will start with wattmeter concept. Okay, thank you.